Let's move to the next question. In this question, the sum of 5th and 7th terms of an AP is 52 and 10th term is 46. We have to find out common difference. Let's work out the problem. We know that nth term of an AP whose first term is small a and common difference is small d, then its nth term is a plus n minus 1 times d. We have sum of 5th and 7th terms, that is t5 plus t7, which is equal to 52. Let's substitute the value of n, which is 5 and 7, in the above equation. We get t5 and t7. We have a plus 5 minus 1 times d, which is 5th term. Similarly, a plus 7 minus 1 times d, which is 7th term, and the sum is 52. Let's simplify this. Here we have a plus a, which is 2a. 5 minus 1 is 4 and 7 minus 1 is 6. Therefore 4d plus 6d is 10d. On right hand side we have 52. Let's simplify it by dividing this equation with 2. Then we have a plus 5 times d is equal to 26. Let it assume equation 1. We have given another condition. Here 10th term is 46. That means T10 is 46. We get the value of nth term, that is a plus 10 minus 1 times d, which is equal to 46. By simplifying we get a plus 9 times d is equal to 46. Let us assume equation 2. Thus we frame two equations, and here we have two unknowns, first term and common difference. According to the question, we have to find out common difference. We have to find out small d value. To get small d, we divide. To find common difference, we subtract equation 1 from equation 2. Now we subtract these equations by vertical method. Here we have second equation, a plus 9 times d is 46, and first equation is a plus 5 times d is 26. While subtracting, we have to change the signs of the equation which is to be subtracted. Here first equation is subtracted, so we change its sign. Here plus a becomes minus a. Similarly, plus 5d becomes minus 5d, and we have plus 26, which is equal to negative 26. And then we add respective terms by considering the signs in the third row. Then we have a minus a is 0, 9d minus 5d is 4d. On right hand side, 46 minus 26 is 20. Thus we have 4 times d is 20. By dividing both sides with coefficient of d, which is 4, we get the value of d is 5. Therefore, the common difference of an AP is 5. And this completes our solution. In this problem, we are given 3 cubes of a metal whose edges are in the ratio 3:4:5, and they are melted, and all these 3 metal cubes are converted into a single cube whose edge is 12 centimeters, and we are asked to find out the edges of 3 cubes. Let's work out the problem. It is given that the ratio of edges of 3 cubes is 3:4:5. If we take x is a common factor, then the edges of 3 cubes are 3x, 4x and 5x. Here we have edges 3x, similarly edges 4x, and here we have edges 5x. And it is also given these 3 are melted to form a single cube. That means the volume remains constant, and we are given a condition that the edge of this single cube is 12 centimeters. To find the value of edges of 3 cubes, we have to equate the volume of 3 cubes is equal to volume of single cube. Therefore, we have volume of 3 cubes, which is equal to volume of single cube. We know that volume of a cube whose edge is small a is a cube, So we have volume of a cube whose edge is 3x is 3x cube. Similarly, the volume of a cube whose edge is 4x is 4x cube, and volume of a cube whose edge is 5x is 5x cube. And the volume of a single cube and its edge is 12 centimeters is 12 cube. By solving this equation, we get the value of x. By substituting the value of x, we get the edges of 3 cubes. 3x cube is 27x cube, and 4x cube is 64x cube, and 5x cube is 125x cube. We write 12 cube as it is. If we take x cube as common, we get sum of 27 plus 64 and 125, and it is equal to 216, and it is equal to 12 cube. We know the value of 216, which is 6 cube. To simplify easier, we write it in the form of cubes. So transposing 6 cube to our right hand side, we get 12 cube upon 6 cube. By writing exponent to both these, we have 12 upon 6 whole cube. 6 goes into 12 2 times. Therefore, we have 2 cube. By applying cube roots, we get the value of x is 2 centimeters. Therefore, we have the edges of cubes 3x, 4x and 5x. We have got the value of x is 2 centimeters. By substituting, we get 6 centimeters, 8 centimeters and 10 centimeters. Let's move to the next question. In this question, OACB is a quadrant of a circle with center O and radius 7 centimeters. If OD is 4 centimeters, then we have to find out area of this shaded region. Let's work out the problem. Here OACB is a quadrant of a circle and radius of the quadricircle is 7 centimeters, and we also have a right angle triangle, that is triangle AOD is a right angle triangle, and the height of the triangle AOD is equal to OD, and we have given it as 4 centimeters. Similarly, base of the triangle AOD is AO, which is given is 7 centimeters. If you look at the figure, the shaded region is not in a definite shape, so we cannot find its area directly. To find its area, we have to take away the area of the right angle triangle from the quadrant of a circle. Let's do that. Area of shaded region is equal to area of quadrant of a circle minus area of right angle triangle, which is equal to, we have area of quadrant of a circle pi radius square, that is AO divided by 4, since it is 1/4 part of a circle, and we have area of triangle half of base times height. We have base AO and height OD. By substituting the values, we have pi times 7 whole square divided by 4 minus half of radius, that is base is 7 centimeters and height is 4 centimeters. Let's simplify this. If you look at this, numerator and denominator contains the same factor, that is 2. So we have 2 times 2 is 4, and we substitute the value of pi, that is 22 upon 7, and on numerator we have 7 square, that is 7 times 7 upon 4, and we have 7 times 2 is 14. Numerator 7 and denominator 7 are cancelled out. If you look at the numerators and denominator, we have 2 is a common factor in 22 and 4, So we left with 11 times 4 on numerator, that is 77, and on denominator we have 2 minus 14. By taking 2 LCM, we have 77 minus 28. Since 14 times 2 is 28, by subtracting we get 49 upon 2. Therefore, area of shaded region is equal to 49 upon 2 centimeters square. Let's move to the next question. In this question, we have cards which are marked with 3, 4, 5 and are placed in a box and mixed thoroughly. One card is drawn at random from the box and we have to find out the probability of the number on the drawn card is divisible by 7. In the next question, we have to find the probability of the number which is a perfect square. Let's work out the problem. Here we have a cards marked with number 3, 4, 5 up to so on 50. From these cards, a card is drawn. Totally we have 48 cards. Out of 48 cards, one card can be drawn in 48 ways. So the number of possible outcomes of the random experiment is 48. Let E be the event that the number on the drawn card is divisible by 7. So the numbers which are divisible by 7 from the given set of numbers, that is 3 to 50, are 7 and multiples of 7, that is 14, 21, 28, 35, 42 and 49. Totally we have 7 possible number of outcomes. Therefore, number of outcomes favorable to event E is equal to n of E, which is 7. Therefore, the required probability is the ratio of total number of favorable outcomes to the total number of all possible outcomes, that is n of E upon n of S, which is equal to 7 upon 48. Let's move to the next question. In this question, a card is drawn at random from a well-shuffled pack of 52 playing cards. We have to find out the probability that the drawn card is neither a queen nor a king. Let's work out the problem. In a pack of 52 cards, we have 4 suits. In each suit, there is a king and queen. From a pack of 52 cards, one card is drawn in 52 ways. So the total number of outcomes is equal to n of S, which is 52. Here, to find the probability of the drawn card is neither a king nor a queen, we first find out the probability that the drawn card is queen and the probability that the drawn card is king. To do that, we have 4 kings and 4 queens in a pack of 52 cards. If we take A is the event which denotes the card is king, then the number of possible outcomes to the event A are 4, and the probability of event A is number of favorable outcomes to A, which is 4, to the total number of outcomes, which is 52. Both numerators and denominators contains the same factor 4. On dividing both with 4, we get 1 upon 13. Similarly, we denote B is the event which states that the card is queen. Number of favorable outcomes to event B is 4 and the probability of event B is 4 upon 52, which is equal to 1 upon 13. We have the probability of queen, we have the probability of king and probability of queen is 1 upon 13. In this question, we have to find out the probability of a card not getting a king nor a queen, which is equal to 1 minus probability of getting a card on which we have either king or queen, which is equal to 1 minus, here we have A and B is the events, so probability of either queen or queen is P of A plus P of B, since A and B are mutually exclusive events, which is equal to 1 upon 13 plus 1 upon 13. 1 minus 1 upon 13 plus 1 upon 13 is 2 upon 13. On simplifying, we get 13 is LCM, and on numerator 13 minus 2, which is 11 upon 13. So the required probability is 11 upon 13. In this question, we have to find the middle terms in the AP 20, 16, 12, so on up to negative 176. Let's work out the problem. Here the given series is 20, 16, 12 up to so on negative 176. By looking at the series, we have first term, which is A, that is equal to 20. We know that common difference is the difference between the term and its preceding term. If we take T2 is a term and its preceding term is T1, then T2 minus T1 is the common difference. In this series, we have common difference is 16 minus 20, which is negative 4. Here, the last term is negative 176. Let it be the nth term. If A is the first term and D is the common difference, then the nth term of an AP is A plus n minus 1 times D, and which is equal to negative 176. By substituting the values of A and D in this equation, we get the value of n. Let's solve it for n. A is 20 and n is unknown. D is negative 4, and the whole expression is equal to negative 176. 20 plus of minus 4 is minus 4 times n minus 1, which is equal to negative 176. Transposing this term negative 4 times n minus 1 to RHS and transposing this term negative 176 to LHS, we get 20 plus 176. On transposing this, we have on right hand side 4 times n minus 1. 20 plus 176 is 196, which is equal to 4 times n minus 1. By dividing both sides with 4, we have 196 divided by 4, which is equal to 49. On right hand side, we have n minus 1. Therefore, the value of n is 49 plus 1, which is 50. The value of n is even number, so we have two middle terms in the given series. They are 25th terms and 26th term. To find these terms, we have the value of first term, that is A is equal to 2 and D is negative 4. Let's find out the middle terms. 25th term is A plus 25 minus 1 times D. On substituting the values of A and D, we get 20 plus 24 times negative 4. That is equal to 20 plus 24 times 4 is 96. So 20 minus 96 is minus 76. Therefore, 25th term is negative 76. Let's find out the 26th term. From the general term, we have a plus n minus 1 into d, and here n is 26. So a plus 26 minus 1 times d. A is 20 and 26 minus 1 is 25. Common difference is negative 4. Therefore 20 plus of minus 4 is minus 4, and 4 times 25 is 100. 20 minus 100 is negative 80. Therefore the value of 26th term of given series is negative 80. Therefore negative 76 and negative 80 are two middle terms in the given series of AP. Let's move to the next question. In this question, a pole of height 5 meters is fixed on the top of a tower. The angle of elevation of the top of the pole observed from a point A on the ground is 60 degrees, and the angle of depression of the point A from the top of the tower is 45 degrees. We have to find out the height of the tower. Let's work out the problem. First, we will draw a simple diagram to represent the problem. Here we have a pole PQ of height 5 meters. Let the pole PQ is fixed to the top of the tower QR at Q, and the height of the tower be h meters. Given angle of elevation of the top of the pole observed from a point A on the ground is 60 degrees. Therefore, angle PAR is 60 degrees. Now, let us draw a horizontal line through Q, and we have the angle of depression of the point P from the top of the tower Q is 45 degrees. Therefore, this angle is 45 degrees. Therefore, angle AQQ dash is equal to angle QAR is 45 degrees. Therefore, angle Q dash QA, which is equal to angle QAR, is 45 degrees. It is because AR is transversal and we have two parallel lines AR and QQ dash. From the diagram, we have two triangles, that is triangle PAR and triangle QAR. Both contains the common base AR. Suppose AR is equal to x meters. By considering these two triangles, we can find the height of the tower. Consider triangle QAR. It is because we have to find out height of the tower. We have perpendicular, that is QR, and base AR. So which trigonometric ratio we will use? We use tan. Therefore tan 45 is the ratio between the perpendicular to the base, that is QR to AR. We have QR is height of the tower, so it is h, and AR is the distance between the observer and the tower, which is x. Tan 45 is 1. 1 is equal to h upon x, which implies h is equal to x. It means the height of the tower is equal to x. We have the relation height of the tower is equal to x, and to find out the value of h, let us consider triangle PAR. Here also we have perpendicular PR, which is the sum of height of pole and height of tower, and the common base AR. So which trigonometric ratio we use? Here we use tan 60. Tan 60 is the ratio PR to AR. Let us substitute the value of PR, which is h meters, plus 5 meters. And we have AR is equal to X, but we got X is equal to height of the tower, H. So here we have H. Tan 60 is under root 3. Let us transpose the denominator H to left hand side. We have under root 3 times H is equal to H plus 5. Let us bring the variable H to left hand side. We get root 3 times H minus H is equal to 5. By taking H common, we have H times under root 3 minus 1 is equal to 5. Now transport root 3 minus 1 to right hand side. We have 5 upon root 3 minus 1. To find the value of H, we have to rationalize the denominator. Here the rationalizing factor of root 3 minus 1 is root 3 plus 1. Let us multiply numerator and denominator with root 3 plus 1. That implies H is equal to 5 upon, here the denominator is in the form of a minus b times a plus b, which is equal to a square minus b square. So we have under root 3 whole square minus 1 whole square, which is equal to 5 upon 3 minus 2. And on numerator we have root 3 plus 1. So we have root 3, 5 times root 3 plus 1 divided by 3 minus 1, which is 2. Therefore, the height of the tower is 5 times under root 3 plus 1 upon 2.